Tomorrow I'm going to have you messing around with some demonstrations involving static electricity. To get you ready for that, I want to go over some basic terms and ideas that'll kind of help you understand what's happening in the demonstrations. Over here on the right side of the slide, I've got 4 main topics I want to cover, and you need to understand each of these by the time the video is over. First off, the law of conservation of charge. The law of conservation of charge says that a charge can neither be created nor destroyed. Now, when we talk about charge, imagine that you've just been walking on a carpet, maybe in socks, and you touch a doorknob and it shocks you. That shock is an exchange of electrons, or exchange of charges. So electrons carry a charge. They're a negative charge. And in the atom, hopefully you've seen this picture before, we've got electrons that circle the nucleus of an atom. Electrons carry a negative charge, and in the nucleus of the atom, we have neutrons, which carry a neutral charge. Neutrons carry a neutral charge. And then we also have protons, which carry a positive charge. Protons are positive, neutrons are neutral, and electrons are negative. When I say neutrons carry a neutral charge, that really means they carry no charge. Anyway, you can move electrons and protons around, but you can't take away their charge or give them a different charge. At least you can't make those charges disappear. So if you were to somehow turn a neutron into a proton, you would then have to have some other positive charge come out of whatever you did to take the charge away from the proton, because the total amount of charge in the universe cannot change. So that's the summary of that idea. Law of conservation of charge says the total amount of charge in the universe is constant. Related to this is the law of conservation of mass. I can move a proton from one place to another, but I can't simply make it disappear. I can move an object that has mass from one place to another, but I can't just make it go away. I also can't cause mass to come out of nowhere. I can't create mass. And so, second main idea, the total amount of mass in the universe is also constant. Whenever we talk about charges in physics, we will generally talk about the charges as multiples of electrons. So if I wanted to say something had a negative charge and I wanted to tell you how much, I might say it has a charge of negative 2e. That would be 2 times the charge of an electron. The unit for charge in the international system or in the metric system is coulombs. And so we'll often relate the amount of charge on an electron to the number in coulombs. The charge on an electron in coulombs is negative 1.602 times 10 to the negative 19th coulombs. And coulombs is C, so that C is coulombs. That's the unit for charge. E negative is the usual symbol for electron, or charge on an electron. So if I said something, in my first example, has a charge of negative 2e, that would be negative 3.204 times 10 to the negative 19th coulombs. I can also talk about positive charges in terms of the charge on an electron. For example, a proton has a charge of positive 1e, which is positive 1.602 times 10 to the negative 19th coulombs. Usually you'll write the number in coulombs. This can get kind of sloppy because positive 1e could look like positive 1 times what's called Euler's number. If you ever use the e to the x button on your calculator, raise something to the eth power, that's Euler's number. And so we'll normally go ahead and write the charges in coulombs, because if we just use E, which is an accepted symbol, physicists sometimes write charge as multiples of E. But if we just write E, it could be confused with Euler's number. And so we'll write the charge of something usually in coulombs. You need to have somewhere in your notes what the charge on an electron is, and then what the charge on a proton is. Now, if you just remember, an electron has negative 1.602 times 10 to the negative 19th coulombs. and that the proton is just the positive version of that, you could do it that way. What this means is, if we have an atom, look at these pictures up here at the top, if we have an atom that has, say, 2 protons and 2 electrons, that atom is neutral. Its total charge would be 0, because if we did 2 times negative E plus 2 times positive E, we would get 0 out of that. Now that we've talked about what it means to be a neutral atom, let's talk about how we can use the law of conservation of charge to determine some things. Let's say I have an atom on a balloon. We'll call this one on the left the atom on the balloon. And the one on the right will be an atom in someone's hair. And we rub the balloon on someone's hair, and one of the atoms in the hair loses an electron to the atom on the balloon. Well, before, both of these atoms had a total charge of 0, had an equal number of protons and electrons, so their total charge was 0. But now, the hair atom has lost an electron, and the balloon atom has gained an electron. Well, if we add 1e to 0, we can now know what the charge on the balloon atom is, and the charge on the balloon atom would be negative 1.602 times 10 to the negative 19th coulombs. What if I asked you, well now, what's the charge on the atom in the person's hair? Well, I know that charge cannot be created or destroyed, and the total amount of charge in the universe is constant. Together, before we started this problem, these two atoms initially had a total charge of 0. So total charge was 0. Well, if the amount of charge I have can't change, that means their final total charge also must be 0. Equals total charge in a system, and in fact in the universe, cannot change. So to keep these two atoms' total charge at 0, this atom has to take on the positive version that the balloon atom did. So now it has a charge of positive 1.602 times 10 to the negative 19th coulombs. So if one atom becomes negative, the other one becomes positive by the same amount. These are all ideas you need to know, especially the amount of charge on an electron. You have that written down somewhere so you can look at it. I'm going to ask you lots of questions involving that tomorrow. And see you tomorrow.